Hello everyone, welcome back to my YouTube channel. In this video, let's solve numericals on single phase transformer. So without wasting time, you can see the first numerical. A 200 kVA, 10,000 bar 400 volts, 50 hertz single phase transformer has 100 turns on the secondary. Calculate the primary and secondary currents, the number of primary turns, and the maximum value of flux. So you can see they are given kVA rating of transformer and primary side voltage, secondary side voltage, frequency, and number of turns on secondary side, that is N2. So see the given rated power they are given. Either you can write VA rating or kVA rating, or else you can call that as apparent power. Yes, they are given that is 200 kVA. You can write it as 200 into 10 to the power 3 volt amperes. Primary voltage they are given, that is V1 equals 10,000 volts, and also they are given secondary voltage, that is a V2 400 volts, and they are given frequency, that is 50 hertz, number of turns on secondary side, that is 100. You will need to find primary and secondary current, so that we know that the kVA rating is given by V into I. Therefore I1, which is for primary side current, VA rating divided by primary side voltage, that is S divided by V1. So here S they are given, that is 200 into 10 to the power 3, and V1 we know that is 10,000, so you can get 20 amperes. Similarly, I2 is given by S divided by V2, that is 200 into 10 to the power 3 divided by V2, they are given 400, we'll get 500 amperes. Therefore, the I1 is 20 amperes and I2 is 500 amperes. In the second point, number of primary turns. So we know the value of V1, V2 and N2. We can use turns ratio, that is V2 by V1 or E2 by E1 equals N2 divided by N1. So here you know the value of V2, that is 400 volts, and we know the value of V1, that is 10,000 volts, and we know the value of N2, that is 100. So we can get the value of N1 by substituting the value of V2, V1 and N2, can get 2500 tons. And the third one is the maximum value of flux. So here we know the values of N1, N2, E1, E2 or V1, V2, and also we know the value of frequency. So can use either E1 or E2, so that the maximum value of flux I am using secondary voltage, that is E2 is given by 4.44 F5M into N2. I know the value of frequency 50 hertz, N2 100 turns, and E2 they are only given 400 volts. I'm substituting the value of E2, that is 400 equals 4.44, and frequency is 50 and N2 is 105 maximum. So which means that we know the value of all the things. We can easily get the value of 5 max is given by 400 divided by the entire terms on the denominator. Therefore, 5m is 0.018 Weber. So this is for this problem. So you can see, first calculate primary current, secondary current, then with the help of this you can calculate N1, then with the help of E2 or E1 you can get the same value of 5 maximum, that is 0.018 Weber. So now we can see the second one. A primary winding of a transformer is connected to 220 volts 50 hertz supply, means primary winding which is connected. So this is V1 they are given, that is 220 volts 50 hertz, and secondary winding has 1200 turns, that is N2 they are given, that is 1200 turns. And if the maximum value of flux is 0.003 Webers, so that we know that flux they are given. And determine secondary induced EMF, number of turns in a primary cross-sectional area if the flux density has a maximum value, that is Bm, if it is 0.465 Tesla. So first given So here the given data V1 they are given, and that is 220 volts. Frequency they are given 50 hertz. N2 they are given 1200 turns, and maximum flux they are given 0.003 Weber, and maximum value of flux density they are given, that is 0.465 Tesla. So can calculate the secondary induced EMF easily. You know the value of N2 frequency phi m. So direct formula E2 is given by 4.44 F phi m into N2. So 4.44 frequency is 50, N2 is 1200, and phi m is 0.003. You'll get 799.2 volts. So now we know the value of V2 or E2, and V1 or E1, and we know the value of N2. The second is the number of primary turns. You can use number of turns in a primary winding. Can use the turns ratio, that is V2 by V1 equals N2 by N1. So here you know the value of V2, V1 and N2. You can get the value of N1, that is 330 turns. Substitute the values neatly and you'll get the same answer, that is 330 turns. And you know the value of flux density, and you know the value of maximum flux, so that you can use maximum flux density is given by phi divided by A. Here I can get as phi m divided by Bm. Phi m you know, Bm you know, you'll get the value of area in terms of meter square, that is 0.00645 meter square. Or else you can write 6.45 into 10 to the power minus 3 meter square. So you can see first given secondary induced EMF, then with the help of turns ratio you can get the value of N1. Then